Solving a system of equations using the elimination method requires that both of your equations be in standard form. We have spent a lot of time putting equations into slope-intercept form so that we can graph them. And that is when you have y equals mx plus b. But we want our equations to be in standard form so that we can combine like terms, add equations together, and have things to be canceled. So standard form is going to be where you have x and then y and your constant on the other side. ax plus by equals c. So that shows here that this equation has the x first, then the y, and then the constant or the number on the other side of the equal sign. So this one is already in standard form. It's good to go. But then I look at this one and it's not quite set up properly. So I need to get the 5x to go over to the other side. So what I'm going to do is just use inverse operations. Anytime you're rearranging or solving, you're just going to use inverse operations to move things around. So I will put the 5x before the 3y because that's standard form, and that's equal to 8. Okay, now that I have them in standard form, I'm going to figure out what I can do to get one of my variables to be eliminated. So if I put 5x plus 3y over here equal to 8, if I add these together, I'm going to get 15x, so that won't cancel. If I add these together, I'll get 13y, so that won't cancel. So I have to think about what I can do to either of these to make one of the variables cancel or be eliminated, hence the elimination method. So I can't multiply 10 by anything to turn it into 5, but I can multiply 5 by 2 to turn it into 10. But I don't just want to have it be the same coefficient, I want them to be opposite signs. So I need this to be a negative 10. In order to do that, I will multiply the entire equation by negative 2. So make sure you distribute and multiply each term in the equation by negative 2. Okay, now that I have multiplied by negative 2, I have x's that will cancel. So I'm just going to write that one under here. And I can add the two equations together and eliminate the x variable. Right? Negative 10 and positive 10 is 0, so that goes away. Negative 6y plus 10y is going to leave me with only 4y's equal to 40, and negative 16 is 24. And then to solve for y, I would just divide 4 on both sides, and I will get that y is equal to 6. And you should know what to do from here. You can pick any one of the other equations. It could be one that we multiplied, it could be one of the originals, it could be this rearranged one. Since this is already set up over here, I'm just going to use this one. And I'll take my 5x plus 3, and instead of y, I'm going to plug in the value of 6 because I know that that's what y is, equal to 8, and then do math. 5x plus 18 equal to 8. Take away the 18 on both sides. 5x is equal to negative 10, and then I would divide by 5, and I get x equal to negative 2. So if x is negative 2 and y is 6, I'm going to write that as a point, xy, negative 2, 6. And that's my solution. Okay, so you do have to put your equations into standard form if they're not already set up for you, and then figure out what you can do to one of them to have one of your variables get eliminated, and solve. Then plug in your value to the other equation, solve again, and you have a solution. And that's that.